Okay, so this is section 8.4, which is the last section for the semester. Yay. We're going to be talking about linear inequalities and systems in two variables. All right, so chapter 8 is inequalities, absolute value inequalities. Everything we've done so far has been inequalities in one variable, and now we're going to do inequalities with two variables, an x and a y. Okay. So when we graphed linear inequalities with one variable, we used a single number line. In this section, we graph linear inequalities in two variables. So that means we have to have two number lines, which we draw like this. Okay, so this is my x number line, and this is my y number line. Usually we call them axes. So my x-axis and my y-axis, aka the rectangular coordinate system. All right, so these would be examples, or this is what a linear inequality in two variables looks like. Notice we have x and a y, and they're both to the first power. No x squareds, no y squareds. So x plus y, and it can be less than, or equal to, greater than, or equal to. Okay. Now, before we go to the next slide, I want to remind you, so let's suppose we have x is less than or equal to 2. And as a different thing, we have x equals 2, okay? X equals 2, we would just put a point, right? But to indicate that we have less than or equal to 2, we have to shade the number line. So all of this shading indicates every number that is a solution to this inequality. As a matter of fact, we would put a bracket. Okay, so the shading indicates that we have an inequality. One more time, the shading indicates that we have an inequality. That being said, when we have a linear equation with two variables, it's an equation. That's just a solid line. But when we have an inequality with two variables, that's when we have to shade. You have to shade, you have to shade. Don't forget to shade. Everyone always forgets to shade. The shading is what makes it an inequality. If you don't shade, it is basically an equation, which is not what we're trying to graph. Okay, so if we take a look at this, the blue, x plus y is greater than 5. And let's take a look at this point right here. If we plug it into this inequality, we have 5 plus 3 is greater than 5. That's a true statement. If I plug in the point 24, I have 2 plus 4 is greater than 5. That is also true. In fact, if I were to look at this point, I don't even know what it is. If I were to look at this point, if I plugged it in, it would be a true statement. It would be a solution to that inequality. Every point that is shaded, every point, every single point that is shaded satisfies this inequality. On the other hand, if you have, let's suppose, negative 3, negative 1, if we put it into this inequality, negative 3 plus a negative 1, this is false. This is false, right? This point right here is not a solution to this inequality. However, it is a solution to this inequality. X plus y is less than 5. So if we need to graph x plus y is less than 5, we would shade all of these points, because everything that's on this side of the line will satisfy this inequality. One more time. I'm going to say this over and over again. It's the shading that makes it an inequality. It's the shading that makes it an inequality. All right, so first thing you're going to do You have to draw the boundary. You have to draw the boundary. That is the straight line that is that would be the equation if we had one. So if we had back to the private, we had x plus y, let's do greater than 5, right? To get the boundary, remember the boundary was x plus y equals 5. So you actually need to draw this first. Now, you may make the line solid if we have an equal to, or you may make it, they say dashed, I always say dotted, I don't know why I have it. If it's not equal to. So if there's no line underneath it, then we have to make it dotted, okay? So draw the boundary line. Then you're going to choose a test point. We only have to choose one point to test it. It's either going to solve the inequality or it's not going to solve the inequality. If it solves it, that's great. Then everything on that side of the boundary will also be a solution to the inequality. If it doesn't solve it, then it has to be the opposite side of the boundary. Here's key. You cannot choose a point that's actually on the line. It has to be a point that's not on the line. Usually we use 0, 0 as our test point, but there is an exception. If the line itself actually goes through 0, 0, we cannot use 0, 0 as a test point. All right, then we shade the appropriate region. One more time. Shade, let me move this out of the way. And then that's gonna, hold on. This out of the way, and move this out of the way. I'll have to move that back. All right. Shade the region that includes the test point if the test point satisfies the original inequality. Otherwise, if it does not satisfy the original inequality, you have to shade the region on the other side of the boundary line. Okay, so I need to, let me move this back so it's out of the way. All right. Come on. There we go. All right, so we need to graph this inequality. X plus y is less than or equal to 4. Okay. The first thing we have to do is graph the boundary line. So we have to graph x plus y equals 4. Okay, and that has nothing to do with that right there. It has nothing to do with it. We always have to graph the boundary, which is the equal. Okay, this is in standard form, so the easiest way to graph is to plug in 0 to find the y-intercept and the x-intercept. Okay, so we plug in 0 for x, and we get y is equal to 4. We plug in 0 for y, and we get x equals 4. So here are my 2 points. When I draw my boundary line, you do have to check to see if there's this equal to. If it's equal to, then we're going to draw the boundary as a solid line. All right. The next thing we're going to do is we have to find a test point. We're going to use a test point. We usually use 0, 0 unless our boundary line goes through 0, 0, which this one does not. So we're going to take 0, 0, we're going to plug it into the original inequality and see if it satisfies the inequality. Zero plus 0 is 0, and this makes a true statement. So because this is true, that means we have to shade on the same side of the boundary line as our test point. So we need to shade over here. Now, you do not have to double check this, but if you wanted to double check to make sure that this side we don't shade, we could use any point over here. I'm just going to pick 4, 4. Plug it in, 4 plus 4. And you can see that this point does not satisfy the original inequality. So notice I'm shading on the other side of the boundary line from a point that does not satisfy the inequality. All right, x plus y is greater than 0. Okay, so first thing we have to do is we have to graph the boundary. Okay, this is the boundary. Again, has nothing to do with an equal to here. The boundary is always equal. Right? So we plug in 0, we plug in 0, and I can already see a problem. What happens if I plug in 0? I get y is equal to 0. So if I plug in y equal to 0, guess what? I'm going to get 0. This is only 1 point. I need 2 to graph. So I need to pick another number for x. Doesn't matter what. Let's do 1. So we have 1 plus y is equal to 0. Subtract 1, and we get y is equal to negative 1. So here are the 2 points that I'm going to plot. And we have 1, negative 1. All right, before we actually draw the boundary line, we have to check, are we going to make it a solid line or a dotted line? Because it is less than, as opposed to less than or equal, there's no line underneath. We're going to make it they call it a dashed line. They call it a dotted line. Technically, it is dashed. All right. So now we have to pick a test point. We cannot use 0, 0 because our line goes through 0, 0. We cannot use 0, 0 because our line goes through 0, 0. So here's what you're going to do. You're going to pick some other point. It doesn't matter what. Okay. So let me pick negative 2, 0. I'm going to pick negative 2, 0 as my test point. So I'm going to plug in negative 2, which gives me negative 2 is greater than 0, which is false. That is not true. It's completely false. So because my test point was false, then everything over here will not be shaded. You cannot shade on the same side as a false point. So I'm going to shade on the opposite side of my boundary line over here. Okay, like that. And we can verify it if you want. You don't have to. Let's do maybe 1, 1. So 1 plus 1 is greater than 0, and this is true. So every point over here would satisfy this inequality. All right. This one is a little bit different. You guys should notice that it does not have an X, which makes it, remember, it's either going to be a horizontal line or a vertical line. So I'm going to subtract 4, and I have y is less than, that's not what I want to do. Hold on. Still want to subtract 4. But remember, I'm trying to draw the boundary. So y is equal to negative 4. Okay. I want to remind you guys, it says y equals. It is not parallel to the y-axis. It's perpendicular to the y-axis. Anytime you have y equals, it's going to be perpendicular to the y-axis. Okay, so it is going to be a line down here. Okay, I have to check, am I going to draw a solid line or a dotted line? And because it's equal to, I'm going to draw a solid line. Okay, now we're going to pick a test point. So let's just use 0, 0. And so I plug in 0 into the inequality now. So I plug it, there is no x to plug in, but I can plug in a y. And this is false. Okay. Everything over here is going to be false. So I have to shade on the opposite side of my boundary line. Shade on the opposite side of my boundary line. Okay. And I am going to stop the video here and pick it up in a second video.